In this example, we are trying to decompose the function h of x into two components f and g so that f of g of x is equal to h of x. So one way we could do this is first let's analyze this function h of x by assuming an input. And I'm just going to pick some kind of random number here like 4. And then let's think about how would I go about evaluating this function at x equals 4. Well, for h of 4, the first thing I would do is square the 4. That's according to the order of operations. The next thing I would do is multiply by 16. After that, I would subtract this from 25. And then the very last step would be to take the square root. So one way that I could look at this is I have inner and outer functions where f is the outer function or one of the last operations performed, and g is an inner function, one of the first operations performed. So probably the simplest way to identify f is the last operation that was performed, this square root function. So when I'm looking at my choices, that would be this particular choice here, that f of x is the square root function, and we're taking the square root of all of this stuff that's underneath the square root, the things that we did over here. But this is a possible answer, and the question is asking what cannot be component functions of f and g. So really by identifying this one, we would take it off our list. And I could go through similarly to analyze the other options. So like in this case, this is suggesting that one of the first functions we did was square x. And actually that was the exact thing that we did over here first. And then after that, we would do this operation. We would multiply it by 16, we would subtract it from 25, and then take the square root. So this is another viable option for f and g. In other words, it's not going to meet the requirement of the question. And then the last one down here, just analyzing this one, this is the one where we did the squaring and the multiplying first. Okay, so that happens first. And then this is going to be the input into the f function, which is exactly what happened over here. Then we would do 25 minus that expression and then take the square root. So again, it's another viable option, so it's one we want to take off the list. So the reason why this third option is not going to work, we could analyze that by actually like doing the composition. Let's find f of g of x, which is probably better written, f of g of x, like this. That's my preferred way of writing it. And I'm going to work this out with this third option. So in this case, g of x is 16x. So I can replace g of x with 16x. And what that tells me is I can replace x in the f function with 16x. So it becomes the square root of 25 minus, and instead of x here, we're going to write 16x squared. Now notice the difference is subtle, but you're not just squaring x, you are also squaring 16. And that's the reason why this particular option would not work as the component functions f and g.